Okay, welcome back, my friends. This is Paul with Logix Magazine, and today I'm going to share a tip, something you should never do, and I'm going to share something you should always do. Stick with me. This is going to be a good one. All right, so I've got a program here. It's a dummy program, and you notice I got all my red X's over here. I kind of wanted to set this up as just an example. I call this Avoid Doing This. That's the name of this program. And I think you're going to see, I hope you see why. If you are writing programs this way, we need to change that right away. This is the sign of a very poorly formatted program. All right, so let's go ahead and get started. I'm going to go ahead and we're just going to take a quick glance at this program. So let's go ahead and page down. Just looking through our main routine. Yep. Got a lot of stuff there. Yep, it's all there. Inputs, outputs. Yep. It's our main routine. Yep. We got our outputs, got our bypass. Yeah, okay, so just like a nice, full, complete program. I think we've captured almost everything we need for this program. We're ready to build this. I think once I make all my tags and get everything set up, my UDTs, everything else set up, this thing won't need any further improvement. Or does it? Okay, here's something I wanted to share with you. I know that in a lot of the training programs, the instructors will show you how to put a program together on the main routine. Or they'll build one routine. And they'll just put the whole program on that routine. And they're trying to show you how the instructions work, how the routine is built, and, kind of for their project. Here's what happens, though. And I've seen this happen in the real world. And I will tell you, this is Tier 1 automotive. I have seen this in some of the secondary companies that I've helped build machines for. They will put the entire program on one routine. All the outputs, all the inputs, all the sensors, all the faults, errors, checks, everything on one routine. Now, for all of you out there who say, no way, it never happened, companies don't do that. Trust me, they do that. And they do it all the time, and they do it still to this very day. It's a very bad habit, in my opinion. What I wanted to share this with you, the reason I want to share it with you, is that I don't want you to look at these programs and then start building programs and thinking that's the right way to do it. It's not the right way to do it. We're going to take a look at how to do it. And then we're going to give you some great pointers about how to build a really good program to at least start it. All right. So this is a habit you do not want to get into doing. Okay. Yes, it takes more work to build out your routines and break up your program the way it's supposed to be. It does take more work, but it's the correct way to do it. It's the professional way to build a program. We're going to take a look at that right now. So the lesson here, in my opinion, just look at this thing. Let's get back down to here. This is all on one routine. Okay. This is a small project. This is not even a big project. All on this one routine. Everything, the whole kitchen sink. Imagine a house that has no walls, because that's exactly what we have here. All right? All right. So I think I beat that to death. So let's go ahead and move on to taking a look at a program that's properly broke up. All right? This is just an example from an old project that I helped work on. Okay, so now what we have is we have our main routine, right? So we have our status, mode selection, nest selection. Here we had some barcode because we were doing some color checks. Okay to run. We have machine home status and our JSR. So a couple of the items that are really important to put on that main routine. All right. Now, there's some stuff here I probably wouldn't have. I didn't write this from scratch. I think I helped work on it, but I didn't write it. So 100%. But, it's got some necessary information on the main routine. Then we have, of course, our auto routine. And an important point here is status sequence 1.0, and it runs all the way down to status sequence 0.31. So from 1 to 32-bit status sequence, right? Then we have all of our file fill. We can clear all of our arrays. Pretty simple, right? Not too complicated. Okay, so here we have homing. Now this one I would have done differently, and we'll talk about that in a minute, but we're pulling all of our cylinders back to a home position. So that's all we're doing here. Sensors, right? All right, so we have all of our sensors right here. All of our sensors. Everything to do with the sensors is on this one routine. Okay, that's it. Everything to do with our HMI is on this one routine, right? So we put all of the information we need for the HMI, on this routine. Production count. The only thing that's on this routine is code that's relevant to production. Okay, here we have all of our outputs. So we're going to circle back to this in a minute, but the only thing on here are all of our conditions before that output is energized. That's it. All of our outputs. The only thing on this routine, outputs. Manual. So here, the only thing that's in this routine are the relevant information that we need to energize an output or a manual input. That's it. Faults, same thing. The only in here is faults, and this is bypass. Anything that needs bypass, any of the inputs or any I/O that needs bypass. That's the only thing on this routine. And so my point here is that's how you should begin to break up your program. Break it up by inputs, outputs, HMI, production, sensors, any of that stuff. The auto routine should only have information relevant to the auto routine. And I will tell you, you'd be surprised how many companies use one routine. There are lots of them, and that's just the way they build their programs. Now, their logic is, if I really need to get into the program, I just dig out the controller tags and I'll find it. And they'll put different heading, run comments and things of that nature to help break that up. But I think that makes it look very unprofessional, much more complicated, in my opinion, to troubleshoot. And feel free to disagree. I just don't believe that that's the proper way to build a program. This simplifies it, makes it easier to find what you're looking for in the program. I think most people who are looking at this could agree with that. Now, that's an example of how you could do it. All right. Now, what you should do, this is very important, and there's some good and some things I would change on this program. So one of the things that I want you to walk away with that you should always do, all right? And that is that everything, let's start with this. So we have sensors here. So all of our sensors. So what we have is we have what triggers our sensor, any faults, errors, anything that nature, right? As we build our own conditions from the left to right. So any triggers, safety, faults, conditions, and then our output, right? So that's how we can structure our rung. In this case, what we have is we have our part present and a bypass, okay? And there's our output on the right. Notice how this is addressed, and this is the point I want to make. What I'm getting is a tag that's a UDT, a user-defined data type that's labeled status. Okay, very important. It's the status that I'm interested. So I don't need this to go out anywhere. I just need to know what the status of this part is. Now let's look at, so that's sensors manual. I need to know what the status of this manual push button is, right? Right here. What's the status? Has it been pushed? Has it been sealed? Is it being called or not called? I need to know what the status of that is. All right. Now, what you don't see is you don't see the status here. Another one you don't seem to see the status on is on the homing the cylinders. But really, if you think about it, isn't that what you need to know? You need to know what the status of your manual inputs are. You need to know what the status of your homing cylinders are. You need to know the status of any faults, any bypasses, the status. For the most part, the only thing that should be an actual output to should be something that goes to a hard wire. All right. Everything else that is on the right hand side, for the most part, right, in my opinion, should always be a status. So that all the status, everything's a status until you get to the outputs. Now the output's a hard physical wire output. Okay. Now you can have some digital outputs as well, communicating to other devices. But for the most part, and the point I'm trying to make is everything here that's on the right hand side, for the most part, excluding the outputs, should be status. Here's why. In order to, in my opinion, and you should look for these opportunities, and obviously sometimes it's not going to work that way. But for this output to be made, I need to know the status of, is the part present? What's the status? Right hand, did it not clear? Is anything missing? Are there any faults, any errors? What's the status of everything else? And if all the statuses are good, then I can make an output. All right. So in this program, we've kind of got it, but not everything. I would change homing all of this to a user-defined data type that indicates the status, because I need to know what the status is of the cylinders before I can permit an output. I need to know what the status is. Manual, right? Any push button manuals, whether it's HMI or physical, makes no difference. I need to know what the status is, right? And I want to communicate that. Here we have a panel view, an indicator light, and there's nothing wrong with that, but I still need to know what the status is. I would have used a status here and then used that status to energize the pilot light and then used it elsewhere throughout the program. The manual push button's been made. In this case, the left-hand part clamps are retracted. It's been retracted, all right, and that's the status of it. It's being pushed and sealed in to the status. And right here we have status cylinder sensors. Okay, so that's in my opinion, the right way to do it. Faults, I need to know what's the status of any fault. So everything, in my opinion, on the right-hand side, for the most part, should give you a status update of that information. And then, for the most part, you would take those and line them up and say all the status of all these items that are necessary to give me an output is in the condition, rather high or low, that I need it to be in. Therefore, I can energize an output. All right? I hope that makes sense. If you have any questions, put them down below. Let me know what you think and how you build programs. And we'll have that discussion. I can share my thoughts and my ideas. But go ahead and put it down below. Let me know what you think. I'm curious. Also, if you haven't been here before, go ahead and subscribe. We talk about everything that you need to know to build an automation career in the robotics, automation, design, engineering career field. And if you want to be notified every time we create a new video, go ahead and hit that bell. So until next time, this is Paul with Logix Magazine. Hey, I really am interested in what you think and how you build your programs. Okay? So until next time, you guys have a good one.